Mental illness is a huge problem, and we can really make huge strides in solving it by using artificial intelligence technology. But without the kind of data sharing that's necessary for machine learning to work, it simply won't be possible to solve this problem. I understand that people value their privacy, and of course so do I. But without data, machine learning technology simply is useless. It cannot be trained without the right kinds of data sets. Imagine.
Good evening, everyone. Hope you're having fun and have enjoyed our sessions from yesterday and today. I hope you guys can hear me well. I know it's been a long day, but we have planned an exciting session for you. And this session is going to be delivered by Tanmay Bakshi. He's a 17-year-old and he has authored 3 tech books for AI and ML. He's been a TED and keynote speaker. He's a Google developer expert for machine learning and IBM developer advocate. And over the past 10 years, Tanmay has been covered in the media. He's been featured on the Toronto Star, Vancouver Sun, and he loves technology. He's also been in Bloomberg Business Week as a young entrepreneur. So let's hear it for Tanmay.
Wonderful. Thank you very much, Prachi. Thanks for having me here on the show. I'm really excited. And yeah, thank you very much, everyone, for joining in today as well. Today's session is going to be really exciting. We're going to be talking about stuff that I personally think is honestly really intriguing. And today we're going to be talking about language model technology. And I know that on the surface, it doesn't seem like language modeling technology is the kind of thing that's super exciting. But what I'm going to do is I'm going to show you all some really fun live demos of this technology in action. We're actually going to be taking a look at a game that I've built to sort of really demonstrate the power of language models and a lot more fun stuff. So I'll be getting to that in a moment. But just before we begin, I do really quickly want to say just a little bit about me and why I'm here. My name's Tanmay Bakshi, and I love working with all kinds of technology. Machine learning technology in specific has been a huge area of passion for me for many years now. And so I've been working towards applying this technology in a variety of different fields that I think it'll make an impact in, as well as actually making this technology more accessible to as many people as possible. Because I feel like there needs to be the resources for everybody, all the way from developers to actually incorporate this technology in their apps, to really everybody to actually understand what this technology is about. So I've been working through this, working towards this initiative really through all kinds of different media, like, for example, my YouTube channel, Tanmay Teaches, where I share my knowledge on all kinds of subjects from machine and deep learning to app development, compilers, and everything in between, as well as my 3 programming tech books that were published last year. And so it's a lot of fun working on these different kinds of content. But of course, though, before we get into this whole language modeling tech, I do want to start off by just quickly saying a huge thank you to the team at the GDG DevFest 2020 for actually arranging this event. I was looking forward to actually being a part in person last year, but then unfortunately we couldn't make it work. But it's great that I can at least be here virtually this year and hopefully in person next year, which will be great. But of course, thank you very much to them for actually putting together the show and inviting me to be a part. It's really exciting. Now, today's agenda is jam-packed with all sorts of really interesting stuff. What I want to do really quickly, though, is I want to take a step back, and I actually want to start off by talking more about neural networks generally and deep learning technology, because that happens to be, I would say, like the main way that we sort of approach solving this problem of language modeling first. Then we'll take a look a little bit more as to, what does it mean to read and write language in the first place. Then we'll take a look at some historic techniques, some new techniques, why they don't work, and what we're doing to fix them. So it's going to be a lot of fun stuff, but let's start off with what is a language model in the first place. Now, the kind of language models that I'm talking about are the kinds that can help us, quote unquote, and I'm going to put air quotes here, write language. So, for example, the kind of classic, GPT type model and these sorts of, autoregressive sampling techniques have existed for many years now. It's one of those, classic techniques where you feed a model with a certain word or a token, and it produces a token, which you then feed back into the model, and so on and so forth. And you just kind of have it do that, and it ends up, again, sort of quote unquote writing language for you by doing this. Now, these language models can be pretty much any function. Usually we use a statistical model, or maybe in this case, a neural network model, to actually run that prediction of what should the next word be in the sequence. And the reason that I think this technology is really important is because if you think about it, we as humans, we are really, really well built to communicate in natural language. And I'll be getting deeper into that in just a moment. But whenever we communicate, there's always some kind of linguistic element to it, right? Even through images or through text or through speech, there's always some kind of language associated with it, whether it's in your brain and how you're decoding the thought or how you're encoding it to share it. So why is it, or why should it be rather, that when we're interacting with people, we can talk to them, but then right as we switch over to technology, we got to start using buttons and dials and switches, right? It's so unintuitive to have to flip your sort of input mode to work with technology. So if we can have tech understand and actually synthesize language just like humans do, then we have this sort of new world of intuitive interfaces that we couldn't have unlocked before. And neural networks happen to be the way that we're approaching this problem today, right? When you open up Google Assistant or when you do a Google search or whatever, you are using deep neural network technologies. Even when you write an email on Gmail, right? You're using deep neural network technologies in order to make your experiences better with the software that you use. And so let's start off by taking a little bit of a deeper look into this language in the first place. Now, as I mentioned, we as humans are really, really well suited to using language. As a matter of fact, we've actually found very specific genes in our genome that are very, sort of well placed or well suited for us being able to understand and synthesize language. For example, the FOXP2 gene. But as is almost a recurring theme, I think throughout this presentation you'll see, these sorts of discoveries are very highly hyped, even though they shouldn't necessarily be. What I mean by that is that you'll see all kinds of news articles on the internet calling this gene the speech language gene, even though that's not really necessarily the case, right? This isn't the one individual gene that helps us with language. There's all kinds, and this just happens to be one of them. But if we take a look at language, again, really quickly, after we as humans sort of invented it and we started to use it, we wanted to kind of structure it so we can make it a bit more formal and actually, know sort of in a standardized fashion what it is that someone means to say with language. And we did this by inventing syntax for language. So, for example, these kinds of syntax trees that you see on screen right now. But the problem with these trees, and the problem with the way that we parse language, is precisely the fact that we are trying to extract syntax. And syntax doesn't tell you what the sentence actually means. It tells you how it's supposed to be structured, and then it's up to the human to interpret that structure and try and figure out what the sentence actually fundamentally means. A great example from Noam Chomsky is the sentence, "Colorless green ideas sleep furiously." It makes no sense, but I mean, it's technically syntactically valid, right? Like if you were to feed this into NLTK, one of those popular Python languages for Python frameworks for parsing language, then you would get the following syntax tree, and it's approximately correct. And so from a syntax perspective, we're all set when it comes to computers. Now, the issue is the actual meaning. Now, the way that we extract meaning as humans is we actually encode, or actually rather decode, this language into, a very complex neural state in our brains. And the issue is that these neural states aren't things that we can just kind of go in there and map out. And so, as with a lot of other problems that have this kind of bottleneck, as developers kind of thought, or researchers as well, actually, why not just apply deep learning to the problem? And it's kind of worked. I almost like to call this Schrodinger's solution in a way, because it works, but it doesn't work in the way that you expect it to. And because of that, it has quite a few quirks to it that you wouldn't necessarily expect. But we'll get into that in just a moment. First of all, though, quick primer, right? How exactly does deep learning work in the first place? And once we understand that, we can understand why it doesn't work well with language. Well, the sort of analogy that I like to bring across is the famous joke of a topologist can't tell the difference between a coffee cup and a donut. I know it sounds weird, but it's true, and not necessarily true. I mean, they're humans, they can tell, but that's not my point. My point is that technically a coffee cup and a donut, they have the same general shape, the same topology. That's because with a series of transformations that follow certain rules, you can turn a coffee cup into a donut. Right? There's only a single hole in both, through the handle and mug and through the hole of the donut. Now, essentially, think of a neural network as a certain set of mathematical transformations that tries to sort of move a space from one shape to another while preserving, of course, that topology, making it so that data can be easily separated in that space. So, for example, if you had a bunch of dots on this mug, then maybe the different colors of dots couldn't be separated with a single straight line on the mug, but if you were to sort of transform that mug into a donut, suddenly you can separate them because of the way you change the shape of that mug. And so that's the idea of what neural networks are trying to do. So for example, let's just say you have this data set over here. Now, this data set is pretty clean, right? So for example, the green and the blue, if you were to draw a single straight line between them to try and figure out where all the blue are and where all the green are, you'd only have like one misclassification, and the red's pretty easy to discriminate anyway. But then if you take a look at the original data set, before it was fed into the neural network, it looked like the one on the left, where suddenly, if you're actually drawing that straight line, you've got all kinds of misclassification. And so what the neural network did is it took the data on the left, and based off of just being trained to identify between the different colors of dots, it was able to suddenly transform them into a space where green and blue are better separable. That's what neural networks do. That's all they fundamentally are ever trained to do. And all this amazing behavior we see emerges from this simple mathematical principle of we want to separate data linearly. And I feel like what a good example or a good stepping stone example would be is the world of images, right? So for example, if we take a look at deep convolutional neural networks like this, and when we train them on cat-dog classification, for example, what's really happening is the convolutional neural network is learning how to map that image into an embedding space, sort of a feature space, where all the different classes are linearly separable, meaning you can draw a straight line in order to separate them, and then the final linear layer, the final layer in the neural network is just responsible for taking a position in that space and classifying it to which class it belongs to, which is very simple for that last layer to do. And gradient descent forces the convolutional neural network to learn this feature space because of the training objective. Because we are trying to figure out that this is a cat, gradient descent sort of just, I guess in a way, ends up finding a good set of weights that makes it so the CNN outputs really good features. But then again, there are all kinds of training objectives that you could use when it comes to images and when it comes to natural language. For example, you don't need to train the network to identify this is a cat and this is a dog. You could just as easily tell the neural network, hey, here's two cats and here's a dog. I want the final output from the linear layer for the cats to be closer than the cat and the dog. And this is called a triplet neural network. Here, you're not telling the neural network to put two different clusters in linearly separable space. What you're doing is you're asking the network to make its more similar inputs according to some arbitrary visual perception are more close together than others. And what this does is it ends up having the neural network learn a completely different set of weights and different outcomes that you want, different user experiences that you'd like to enable call for different training objectives, because that fundamentally changes the way that the neural network learns. And, we as humans, even though we are very, very dissimilar from the way that these neural networks and machine learning algorithms work, I still feel like there are a couple of interesting parallels that we could draw. For example, one of my good friends, my mentor, Timothy Duncan, he wrote an article that I really love. It's called A Tale of Two Police Departments. And it talks about what happens when you set the wrong objective. And there's one particular sentence in this article that I really love. And he says that in order to stop the spread of drug sales, in the US, police departments were incentivized to just make as many arrests as possible. And as you can imagine, that leads to the situation that we see today. Now, the issue, what I'm sort of trying to get across here is that whenever we have these neural networks, which are essentially just large mathematical optimizers, or even people, right? Even we as humans, whenever we're given an objective, when that objective is set, there's a certain intention of how we want people to get there, right? We want police departments to stop the sale of drugs, or we want a neural network to write language. And so we set an objective, a training objective. But the entities actually responsible for achieving that objective are fundamentally lazy, and they will always find the easiest possible way to achieve that objective. So whenever you engineer an objective, you have to be very, very careful with the way you do it. Otherwise, whatever it is that you're trying to train or measure simply isn't going to do it well. Because again, fundamentally, neural networks are large mathematical optimizers, and the training objective is telling them not just how to learn, but also what to learn, what knowledge to embed within the weights. And so that's something that I think is really important to keep in mind. And now we can finally extend this analogy into the world of language. And language sort of has two major pillars to it, if you see. There's reading and there's writing. But really what I like to say is that they're more similar than they are dissimilar, right? Reading and writing are really just the same thing when it comes to neural networks. They're just sort of two different ends of the same coin, almost. But still, though, let's start off with what we stereotypically associate with reading, and then I'll sort of get into how that leads us to write with neural networks as well. So let's start off with one of the classic techniques of neural networks. This is called word-to-vec. All right, this is something that you've probably heard of. Word-to-vec is this fun technique where you take some input, so a single word, into a neural network, and you have the neural network predict, say, like 2 words that came before it and 2 words that came after it. And what this does is, again, based off of this training objective, we sort of force the layers that come before the final layer to embed every word into a space where their position in that space encodes semantic information, not just syntactic information. Of course, syntax info is still there, but semantic information also is forced to be encoded. Otherwise, you can't really predict context. And what this means is that once you're done training this network, you can just feed in every single word once more and then store in a database these sorts of mathematical representations, these points in a space that represent every single word that you have in the training set. And what this does is it gives you a kind of semantic projection of all these words, meaning you can quite literally do word arithmetic. So you could do king minus man plus woman, so using all those vectors, and the resulting vector would be incredibly close to the one for the word queen, right? That would be its nearest neighbor. And so these neural network techniques were pretty great, but they had their limitations. And I'll get to that limitation in just a moment. But first, we actually have to use these word vectors somehow. So the way we use them is by using these sorts of fancy recurrent neural networks called LSTMs, which are responsible for understanding data over a time series. Now, if you think about language, for example, the sentence, hello, how are you? It's a time series, right? So the word hello will change the meaning of all the words that come after it. And so you can think of language, you can think of a sentence as a series of data over time. And let's just take a look at how these LSTMs work, shall we? Well, the way it works is actually pretty simple. The 4 sort of LSTM cells that you're seeing on screen right now are actually the same layer, and they feed into, well, itself, or on the slide at least, each other. And so, for example, you start off by feeding into the first LSTM cell the word hello, and the LSTM cell generates a hidden and a cell state, which is then fed back into itself with the next word, which then generates another hidden and cell state, which is, you just keep using those new hidden and cell states over and over throughout the time sequence. And then finally, what you can do is take that final hidden state and feed it into another neural network that's responsible for doing a classification or whatever it may be. And because of the way these LSTMs work, they're pretty elegant to do multi-layers on, right? So you can take every time step from one layer and move into another layer and capture even sort of deeper patterns within the data that you're trying to analyze. But the issue with these LSTMs is, well, actually, they have more issues than they have solutions. One of the issues with them is that traditionally the way we've trained them is incredibly domain-specific. Right? We would create an LSTM trained just for the task of sentiment recognition. Then we would create one for entity recognition, and so on and so forth, maybe semantic parsing. And the issue with this is that each network is just learning its own patterns. It would be so much more effective if we could have them all learn from the same general corpus of text and then specialize these networks to do individual tasks. So that's a bit of foreshadowing for what we'll see in just a minute. But another limitation to this is that these LSTMs can only see back or forwards at once. They can't see both ways around, and that limits contextualization. And that also means that they're really, really slow. Every time step depends on the computation of every time step before it. And that just adds on to their plethora of issues. But they were still pretty competent. And so we used them for all kinds of things, better than nothing. And so we did, sentiment classification, review quality detection, named entity recognition, all kinds of things with LSTMs. But again, it's all about the issue of contextualization. The word live or live, they're even pronounced differently in this case. The words live and live in these two sentences, they don't mean the same thing at all, but a word vector would still give it the same representation, and an LSTM would technically contextualize it a bit, but it would be difficult for the LSTM to do so because it can only look in one direction. And so what we realized that these LSTMs have all kinds of issues. Again, I mentioned it being slow. Remember that each LSTM depends on the computation of the ones before it, and therefore you can't really parallelize it even if you have tons of GPUs lying around to do so. And so to solve these issues, there's a paper by a team at Google, actually, which is pretty incredible. It's a classic paper now called Attention is All You Need. And this paper introduced the transformer network, which we're not going to be getting into right now, well, we will in a moment, but then that evolved to the next technology that I'm going to talk about called BERT. Now, BERT is one of my favorite neural networks of all time because it has really revolutionized the way that we do natural language processing. Not natural language understanding, processing, but we'll get to that in just a moment. What BERT does is it solves a lot of the issues that these LSTMs had, right? It's very fast, at least compared to LSTMs, because the transformer architecture fundamentally allows for a lot more parallelization than an LSTM ever could. And it's also very, very contextualized, right? It's able to look at the entire sequence of words that you feed it at the same time. The way BERT is trained is really genius. It's trained kind of like how we are as humans. We take random sentences from the internet and we just mask out words at random, and we have BERT predict what those words were. That's literally it. And what happens is BERT ends up learning really, really good mathematical representations of what different words mean. And it's able to do this because, of course, in order to predict masked words, it's got to learn about the world. It's got to learn about what we write and how we write as humans. Another major innovation with this network is word piece tokenization, meaning you no longer ever have out-of-vocabulary words. Words that aren't in the vocabulary are split up into smaller tokens that are still in the vocabulary. And now you can use this pre-trained BERT network that has this general language understanding, and you can actually use it in a downstream task, for example, sentiment classification, and it already has a bunch of weights that help it understand language. And because of this, you get much better performance on your final task. Now, what I've done already is I've built a sort of smaller version of BERT that you can actually see on my GitHub right now. It's called Artist BERT. And what it does is it sort of shows you the sort of core concepts of the BERT neural network. And I'll just quickly sort of run through it right now so you can get a better idea of how it works. But if you'd like to take a look at a demo and the actual code, feel free to go to my GitHub to take a look at that. Basically, what we do is we start off by taking, in my specific case, an artist name. And what I do is I go ahead and, of course, lowercase it all, because my implementation is super minimal. I don't want many characters of input. It's all lowercase. Then what I do is I mask out some characters at random. Let's just say we mask out the very last character in this case. And of course, since my implementation is minimal, I don't use the full mask token. I just use a capital M to represent a mask. Then what happens is, to start off the transformer, you've got to embed these individual characters into an almost word-to-vec-like space where each character is given its own individual representation, non-contextualized. But that's very easy to do, right? It's just a couple of linear transformations. It's literally everyone maps to a single point in a certain vector space. Now, what's really interesting about transformers is that technically they weren't meant to work with sequence data. Well, they were meant to, but they don't inherently have an understanding in the rest of the network of where characters are in the sequence. And so what you need to do is you actually need to embed the positions of the characters themselves as well, and the segment that they're a part of. And then you've got to sum those vectors with the actual character embeddings in order to get the final embeddings that encode positional information. And then the rest of the transformer can actually look at that positional information and know where each character is relative to each other. But then essentially what we do is take those embeddings and sort of feed them into these things called self-attention layers, which again are a pretty genius concept. Essentially what you're doing is you're taking every character and you are checking at every sort of self-attention layer how much information from every character should flow into every other character. And what this does is it makes it so every character is actually interacting with every other character. That means we do have n-squared memory complexity, but that also means that it's really good at understanding language. Now, there have been some initiatives and sort of derivative networks that don't have this complexity, but they also perform very well. But the original BERT is what we're talking about now, and that's how its self-attention layers work. Now, what I've done is I've built a demo of this technology in action that I would love to show you now. It's a quick demo. And then from there, I'll talk a little bit more about actually writing with these language models. And then if we have a couple minutes, I'd love to answer your questions as well. But really quickly, though, let's take a look at this demo I was talking about. All right, so what I'm going to do over here is I'm going to open up QuickTime. And over here, I've actually got my phone on screen. Now, on screen, I've built a little application. And what this application does is it implements a bot that plays the wiki racing game. The wiki racing game is basically this. You're given two random Wikipedia articles. You've got to go from one to the other. How do you do it the fastest way possible? Well, I built a bot to do it. You can only click on links in every article to move towards the final goal. So for example, let's just say I were to go from a wombat to apple. That's pretty simple. We're going from an animal to a fruit. So I click on find a path. And what's happening is I have an A-star pathfinding algorithm that's actually live going to Wikipedia as we speak. And it's scraping information off of the Wikipedia page in order to pathfind its way towards Apple. But because I'm using A-star, I have the option to give it, well, I have to give it a heuristic function so it knows where to look. And what I've done is I've trained a BERT model in order to actually predict that heuristic to let A-star know where it needs to move. Now, what I'll do is I'll give it a little bit more of a complex example because, as you can see, it was able to solve this pretty quickly. And as it finds a path, I'll explain the way it works. Now, what's happening on screen right now is it's trying to find a way to go from the Wikipedia page for water to the Wikipedia page for Power 10, which is IBM's newest power processor. Now, as you can see, we've already got the neural network sort of chugging away at looking at Wikipedia. But let me tell you how I trained this model in the first place. What I did is I took the BERT neural network, so the pre-trained BERT from Google directly. And what I did was I sort of trained it myself, fine-tuned it on, oh, there we go, it found Power 10. But what I did is I fine-tuned it on a data set from the IBM Project Debater team. And this Project Debater team put together a demo where they would be able to figure out the relatedness between different terms based off of human ratings of 20,000 Wikipedia article pairs. And by training BERT to do this, I'm able to have BERT actually find a path from any Wikipedia article to any other Wikipedia article by predicting the relatedness between an article and the goal. And this sort of just goes to show the power of the BERT network, even when it comes to something so open-ended as just looking at the title of a page. Being able to understand the context of those words is truly incredible. And sometimes you'll even see it almost behave like a human, right? Sometimes it'll misunderstand the control flow as a programming concept as a water-related concept, and it'll actually try and go into those Wikipedia articles. So it does make mistakes sometimes. And what I think is really incredible is the sort of hidden knowledge that it captures. So for example, let's just say we've got a parse tree like this one. It's pretty amazing, but even though BERT was never trained on these parse trees, still, if you were to do linear probes on the embeddings that it outputs for every word, it still approximates those syntax trees internally. So mathematically, it implicitly figured out these parse trees that we as humans developed for our language. If anything, I think this is almost a gift for linguists because it almost mathematically proves the sort of validity of the way that we structure natural language as well, and even shows that neural networks are capable of simulating that structure without ever having been trained on it. But now, though, we've talked a little bit about reading. I do want to make a quick note about writing with neural networks as well. And you see, when it comes to language writing, I feel like really what we're doing as humans is we're never really just synthesizing language. We're trying to take different inputs from our brain, right? Different neural states. We're trying to encode them into a format where other humans can decode them into similar thoughts. And while this entire sort of pipeline of going from neural states to text and speech is really difficult, the really sort of easy part is just the raw translation of a thought to language. So for example, translation networks have worked very well. Google Translate is an amazing system. But then when we sort of take this similar technology and we just take the autoregressive sampling magic and we have neural networks write, we suddenly have much worse output because with translation, the original thought was already there in the source language. All the neural network had to do is translate. But when it comes to autoregressive sampling for writing, the neural network has to ideate from scratch. And well, that's not really something neural networks are great at doing. You see, what's happening is we're almost training these neural networks to synthesize thoughts from language, which is the other way around from the way that we do it as humans. And plus, we even sample from these neural networks wrong. We train them with greedy sampling approaches, but then we try and sample them with probabilistic approaches. And just generally, these neural networks are not given a fair enough chance to do what we want them to do. In a way, I like to say that these neural networks, things like GPT-2 and 3, for example, are essentially neural networks that were trained to read that are masking as neural networks that were trained to write. So if you take a look at the famous unicorn generation from GPT-2, for example, you'll notice all kinds of very weird, sort of parts where it understands language. So for example, it understands Argentinos in South America, but it'll also have these sorts of parts where it doesn't understand the intricacies of the language or the story that it's trying to get across. But still, that doesn't stop pretty much every news outlet out there from saying that this is going to replace everybody from marketers to developers, because now apparently GPT-3 can not only write articles, but even code for developers. But of course, this isn't going to happen, and I feel like the best way to describe it is quite literally to just take a look at the OpenAI website, right? Nowhere do they say that the OpenAI GPT-3 is, the perfect language writer. These neural networks are not really meant to write. They may have been trained with an objective that looks to us as writing, but it fundamentally, at the end of the day, is still just a really large neural network that was trained to read well enough that it can almost imitate a writer. But fundamentally, writing isn't just about synthesizing language out of nowhere. Writing is about being able to take human thoughts and experiences and synthesize them somehow into a format that other humans can understand. So the real problem here is not language synthesis. The real problem here is thought synthesis, and then being able to translate that to language. Now, this is definitely a field that researchers are working towards fixing. There have been lots of strides made very recently, for example, by Facebook Research and their unlikelihood training objective. But I'm sorry to say there simply hasn't been enough work done to say this is how developers can ship this in an application today. Unfortunately, that kind of work just hasn't been done yet. Now, it is being done. There's data sets out there, for example, the Common Gen data set, which is responsible for taking just random entities and constructing valid stories out of those entities. And today's neural networks absolutely fail at it. They don't even come close to human performance. And the day that we can solve problems like the Common Gen dataset, and not just things like the Winograd schema to detect pronouns, that's the day when we can say that neural networks genuinely have enough reasoning and common sensibility to be able to synthesize natural language through thoughts like we as humans do. But that was what I had to share about the world of language models and how this technology works. All this code is being open sourced very soon. The Artistbert's already on my GitHub. And of course, the Wiki Racer will be available as a YouTube video on my channel, as well as the code later this week as well. And so hope you enjoyed that demo, and hope you sort of derived some insight from what I had to say about the world of language models. This is really exciting to me. But if we do have a minute, I'd love to answer any questions you may have as well.
Hey, Tanmay, thank you for this session. It was really insightful about the language models and neural networks. We do have some questions. One question is why most researchers are still shifting from TensorFlow to PyTorch.
I would say that maybe there's more of a trend towards a couple of researchers or maybe students using frameworks like PyTorch because of the fact that they work better or more simply for certain tasks. And also because there's almost this sort of stigma that used to be associated with TensorFlow of, you've got to build a whole computational graph and you've got to compile it and then run against it. Nowadays, TensorFlow has started to become, pretty much as intuitive as the, implicit internal graph building approach of PyTorch. So I don't see that trend really accelerating so far. As a matter of fact, I think more people are starting to move towards TensorFlow because of technologies like Swift for TensorFlow that sort of enable the next generation of machine learning. But mostly it's because there used to be that stigma attached to TensorFlow. And then PyTorch was that great solution. Then a lot of people started to switch to it. But now there's that sort of mix between that and Swift for TensorFlow. But hopefully that helps.
That's great. I hope we've answered your questions, Shiva. The next question is how to apply early stopping procedure in multi-layer perceptron model in Weka.
I haven't used Weka for I think 3 years. Actually, it's I haven't heard that name in years. So it's great that you reminded me that exists. But I'm not sure if many people use Weka anymore. I'm not sure if it's a tool that you should use. What I would recommend using would be something like Keras, since that's a lot simpler, and so you don't need to learn the full-on TensorFlow, sort of toolkit. So I would recommend working with something like Keras or TensorFlow, first of all, right off the bat. But in terms of Weka, I don't exactly know. I will. You can probably reach out to me directly over email, and I can go ahead and help you. But off the top of my head, unfortunately, I do not know.
Perfect. Any more? Okay, so we have another question that is, what is the scope of machine learning in automation in next 10 years?
Oh, very nice. Gotta say, automation is one of those fields where I feel like machine learning is incredibly useful, because machine learning is all about being able to identify patterns in data and being able to autonomously make some kinds of proto decisions based off of that. And within automation, I've actually personally seen in a couple of different organizations that I've worked at that machine learning has been used wherever there is data and that data is being used by a human to make a decision. And we usually know the classes of those decisions that are made. So for example, a human will manually look at some data and identify A, B, C, or none of the above. Like whenever there's those sorts of problems where humans are doing that kind of structured translation of even unstructured data, that's where machine learning is really helpful. So that is pretty high level, I do understand. But basically, wherever you see that humans are taking data and they're translating it to some structured output, that's where machine learning technology is the most helpful.
Perfect. That's great, Tanmay. So what I would suggest to our viewers is you can definitely connect with Tanmay on all the social media channels. He's on Twitter, he's on LinkedIn. And then, okay, so we have another question for you. What are your views regarding importance of semantic analysis?
Very nice. I gotta say, semantic analysis of language, I mean, as you've probably seen through the talk, is sort of my entire area of interest, because I feel like we've done a lot on syntax, we've done a lot on token level, techniques. We really, really need more sort of focus on applying neural networks to understand the semantics of language, because that is what's really important. And I say that because, for example, we've seen techniques like TF-IDF, which is great for just being able to simply search documents. But at the end of the day, if we want to do things like question answering, we have to be able to understand the raw semantics of language as well. So I would say it's really important. Lots of researchers are working towards it. BERT's the perfect step in the right direction. We've seen lots of evolution since then. And there's still more work happening, and I can't wait until we actually have neural networks that have common sense reasoning abilities.
That's great. We have more questions coming in. One more question is, how do I start deep learning?
Wonderful. Okay. Thanks for asking that, Cecily. How do I start deep learning? Well, I would say there are a couple of different great resources out there. If you don't already have experience with programming, then there's my book, Tanmay Teaches Julia, which will help you get into the world of programming and also introduce you to the world of machine learning at the end there with the Flux library. But apart from that, if you do know how to program in Python, there's a new YouTube series that I've actually launched called Learn Deep Learning from Scratch, which teaches you enough of the mathematics to get around in the world of machine learning. And that series, I will be uploading more tutorials this week within actually a day or so. And so hopefully that's helpful helpful. But generally, I would say, using frameworks like, for example, TensorFlow, Swift, or TensorFlow are great to get started, and hopefully my resources can be of help.
I think that's great. Okay, we have more questions coming in. One more question. What are your views on Neuralink?
Okay, I gotta say, Neuralink is very interesting to me, first of all, because I feel like brain-computer interfaces generally is something that I've been interested in for a long time. Like, I've been working towards, you may know, a previous project of mine, which is sort of progressing more slowly due to hardware issues, around being able to understand enough of someone's electroencephalogram to provide them with a sort of artificial communication ability, if they can't communicate naturally. And so I've been interested in BCI technology for some time now, and Neuralink is definitely, again, I would say, moving towards that future that we want to see of being able to analyze EEG data with enough resolution and speed and accuracy that we need. But the only issue with it is that it's quite invasive, right? What we really want in an ideal world is something that works just directly on your head without needing to actually implant anything physically within your brain, regardless of how small or painless or upgradable it may be. And I feel like that's something that we haven't really worked towards with Neuralink yet, but hopefully in the future, right? It's definitely promising. I can't wait to see what we can do by analyzing the data coming off of our brains, but it's incredibly more complex than people might think.
Mm-hmm. Another question, can you give viewers any idea about your another book in 2021 if you're launching some book?
Definitely. So yes, I am actually launching a new book on the Go language, which is coming out very soon in 2021, as you mentioned, Shiva. That book is going to teach you all about the world of the Go language. It's going to teach you concepts like concurrency, and it's also going to touch upon the internal Go runtime in the compiler. So we're going to be building applications that actually do interoperability between different languages, including Golang and Swift and C and more. And I'm going to be showing you how you can actually sort of understand the concepts of concurrency and Go routines and channels and these sorts of things, and how the compiler actually implements them. So it's going to be a really fun book. I'm writing it with my friend Omer, and so hopefully you enjoy it. It is currently available for pre-order.
Wow, that's great. It gives me an inspiration to sort of go ahead and read that book.
Thank you.
Okay. Perfect. So it was great, and I would request the viewers to follow Tanmay on social media, and thank you very much, Tanmay.
Thank you very much. Glad to be here. Thanks for having me on.
Thank you. Bye-bye.
Bye.
We have our next session that will be starting. I would suggest Shweta to introduce. Okay. So while Shweta is away, I can talk about it a little bit. Hi, Shweta.
Hey, Prati. Thank you for your session with Tanmay. That's really interesting. And we got lots of questions from the viewers, and that's really good.
Yeah, so I would give you the stage here, and you can talk about women in tech. We've been empowering women and talking about women in tech sessions for a long time now.
Yes.
So let's hear it from you.
Yeah, so today we are welcoming Kubra. She is Developer Relations Program Manager in Google, and she started her career long back. As we are a GDG group, she also started her career as a GDG. Then
Okay, cool.
hey, Shubhra. Hi.
Okay, hi. I was just waiting for the video to stop. Actually, I got confused, but yeah. So thank you. Actually, I'm glad that I'm here, and then thank you, Shweta, just for introducing me. Hopefully, I will just talk about all the like challenges that we are having as women, and then how Google is helping all the women in tech. So first of all, of course, welcome. It's great to have all of you here for the session at GDG Cloud Toronto's DevFest, of course. And then my name is Kubra Zengin, and then I'm the regional lead for GDG and WTM programs at Google. Like Shweta said, it's been almost 3 years that I'm in charge of GDG and WTM programs at different levels so far. And today, again, like I said, I will be sharing my own story about how I get into tech, how Google Developers Program Women Tech Makers help thriving women in tech, and some other challenges and successes women in tech have. But first, I would like to share this one. This is one of my favorite quotes in life, actually. So I say that where there's a will, there's a way. Because remember that like every step of your comfort zone is leading your growth. Unknown is kind of scary, intimidating, at the same time, remember your moments that when there's a chaos or downtimes like we are all going through right now in the world with coronavirus, economic struggles and everything. So you turn your ashes into a brilliant person that you are right now as women. So that happens actually with some curiosity and a pinch of courage, right? So I believe all of us as women have that curiosity and courage inside of us. So that is actually leading us to growth. So when you fear in a specific situation, then it will, actualize itself and you fail. Instead, I'm like telling all the women around me, like, embrace the unknown, become like a newborn to the situation to handle it. So like, why do I say, become a newborn? Because, they don't know about the world they're born into. They explore the unknown with curiosity. Sometimes it hurts, sometimes, it scares, but then they grow and learn. Same here, right? So it's just in every situation, every single situation, if you think you are a newborn and then the growth comes. The beauty of being an experienced adult actually makes the situation assessed in a logical way too. So what I'm saying is that, like you can balance things out with your logical mindset and then also keep your childish curiosity as women to grow yourself and the people around you. So with that said, so this is like the, whole mindset that I have in my side. And then I'm trying to, just lift other women in tech up so we can just, join the forces, like come together, be stronger, and then we can kind of, conquer the world. So I can tell. But before that, after this, so I would like to share how I get into tech. It's interesting. People like this story a lot. I'm kind of a little bit like being on the spot sometimes, but yeah, let me share. Hopefully it might be inspiring, or if you have any questions regarding my story, feel free to just, shoot an email. I will share later on in the last slide of my deck. So I was born in Istanbul, Turkey, and then which, is a developing country with lots of problems in it, like many other countries, but not with great opportunities like here in the United States. So you cannot change your birthplace, of course, but you can change your opportunities that I was thinking. Then I was thinking, how can I kind of just change my environment too, right? So I will explain in a bit, but fast forwarding to college, I studied chemistry with the systematic patterns of the given structure in the education system in Turkey. It's like you go into an exam and then you get a high score and then, you just end up in a college. But I was like, okay, after, giving some thoughts into it. Do I want to do this still? Like, is it, good for me? I studied it, like, right? So after graduating, I was, is it too late to just change it? Or like, do I enjoy this? Or like, those were all the questions that I was kind of, struggling with, and then trying to figure out what should I do next. Then after a year or so, I wanted to just, decide not to pursue chemistry. So that's how actually, how can I say, it's just the way it worked was like, I didn't have, like role models in my family or around me. At that time, I was like, I always wanted to be an accountant, like my aunt, and then she was the only person that I looked up to with a greater inspiration, interestingly. So I never wanted to be an astronaut. I never wanted to be a dancer, pianist, etc. But thank God, sometimes in life, what you don't want leads to what you want to do, right? So chemistry, in that sense, like, just I didn't want to do it. Then I was kind of figuring out, okay, what do I want, right? So I just sat down with my friends, family, and I was like trying to, question, okay, what do I like? I was so enthusiastic about tech. I was the first person to just download all the beta of the products, or like just trying to patch everything back in time, like 2000s. And then I was trying to kind of learn more about tech, so I could just go into that direction. So then I met my old boss at a conference. So with all the things that I was trying to do, right? So I was just going into the conferences. I was trying to just well prepared for all the tech issues and all the tech learnings, like from blogs or articles, or like all the videos. So I can just tell, okay, I'm ready to just maybe get an internship. Like, it doesn't have to be something big, right? So I was so lucky. I went to that conference actually, and then I told my old boss at that time, like, okay, I studied chemistry, but I'm so enthusiastic about tech, and like, what can I do? I asked, and he said to me, like, send me your CV, resume. And I was like, okay, yeah, that's amazing. Like, 23 years old, okay, I'm out of the college, and then I'm trying to just battle with all the struggles that I have to find a job. And that was the lucky time. So maybe as a learning, I can tell now, like, if you don't ask, people don't give you opportunities, right? So you need to ask for those opportunities. You need to just hustle. You need to just go, in that mindset of hustling, and then kind of, okay, I want this, and then how can I get it? Like, just put out all of your options on the table. Then you will be able to open those doors easily. So at that time, I started as an intern at that company, at a small agency for product development and marketing. Then I got into a full-time, which was great. Like, I was so happy. So my passion, actually, this is something that I would like to call out again, like in this story. Like, if we just extract some points of my story, you can see, like, pursue your enthusiasm, ask for opportunities, right? So follow your passion. So those are the things I can tell right now, like, from my story. But so maybe I should just continue. Followed my passion for UX design with another company. At that time, I was like, okay, I learned so much in the marketing field, but what do I want to do next? And at that time, like, there was again a good opportunity for me in the UX field. So I got into that agency, and I worked as a marketing person in the UX field. So I can just, again, be well prepared for the UX area. user experience area to just work maybe as a UX designer, as a next step. So I always use my current situation to go to the next step. Like if I wanted to just switch the career a little bit, into what I want or what I'm passionate about, I use my current one, for example, marketing field, to just be in the UX field at that agency, so I can, learn more around the people around me, from the people around me. So that actually led me into another position that I can tell, like right now, that was the biggest opportunity. Again, they just called me one time, like I was out, and I remember still how I got excited because it is the biggest career website in Turkey. So it's a big corporate company. They told me, "Oh, would you like to be specialist for UX and product development?" Of course. And then I got into interviews. I just passed them and everything. So I started as a product development and UX specialist at that company. So then the other one that I was actually enthusiastic about, like as a next step, I can tell, startups. So I tried, agencies, big corporate companies, because I was still trying to figure out what I wanted to do, right? And then startups. With all the learnings that I had, for my own career, that led actually to another field. Okay, I want to just be like in the startup field, to just build a product from scratch and then scale it off. That I was really lucky again. Like in San Francisco, there was a San Francisco-based company that I worked for, as I was saying, like as in startups. And at that time, actually, I still wanted to do, some other different areas. Like it's just, trying to grow myself all the time. I will just share this actually, which is interesting. So while I was working at that corporate company as a product specialist, product development specialist, I started a community which was about tech. So that was my goal, was always, okay, let's bring all the people together and then kind of teach them how to do things, or maybe let them learn from each other, or maybe create a synergy that they can work together on a project or something. So it was called Tech Meetup. And then it was really a big thing in Turkey at that time. Then that led me to meet my friend at Google, Nilay. Maybe you might have heard of her. Actually, she's working in Flutter at Google. So she and I and lots of people, lots of women, we organized DevFest Women in Turkey. And then we had 1,500 people at that time for that event participating. And it was a success. I'm really happy that, I was in the community, I was helping people, and also learning by myself how to just, kind of grow myself still. So fast forward then from that moment to that time after, I was getting a job in the startup field, Nilay, who I worked with at DevFest Women time, just told me, okay, my contract is ending at Google. Would you like to be, interested in just getting my old position? I was like, okay, what is it about? Of course. So I got that interview at Google as a contractor, and then I got in. I was so happy, of course, 2 years ago, 3 years ago, I forgot. But I will tell this as a point, right? So again, what your passion like about my, Best Women event, that passion led me to get a job like at Google, because the network is really important. You don't know where the opportunity comes from. So please, 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 follow your passion so you can, like open all the doors around you so people can know you, like just bring more opportunities for you. So still, that didn't actually end. So I wanted to just get more, like how can I grow myself with all of these. So I got into a full-time position last year actually at Google with all the things I worked for the community itself. So I love being around people. I just want to create more opportunities for people. So that's how actually I would say, just make sure you are following your passion all the time. Like otherwise, no, like it doesn't, bring any opportunities to you. By the way, in the meantime, I forgot to mention, I like to get out of my comfort zone. I went to Chicago, like to study after a while, for some time. So from that company that I worked for, like in San Francisco one, I got fired from that one. Like it was so like trying to figure out what I want to do next, right? So it's just try and learn, and then you just hustle. So yeah, I'm really happy about where I am right now. So hopefully this is an inspiration for just even one of you. I'm kind of sharing this story because I know like some people really like it, but yeah, that's the whole point of view, like to takeaways, like I can tell those are the things I just learned. So the thing that I want to just share with all of you is just how Google, Women Tech Makers program helping thriving women in tech right now. So as I said, I'm here like for 2 years, and then I've been working with Women Tech Makers team about this one to how we can, just help women in tech. How can we just have this low barrier entry to tech, so we can just provide more visibility, more community, more resources for women in technology. So Google's Women Tech Makers program provides, as you know, visibility, community, resources for women in technology. So you can see the website over there, and I will talk about what we are doing as Women Tech Makers team. So since 2014, every year we bring like thousands of people, women in technology, through our events and technology near you. So what we do is, like, you can just see the pillars: events, ambassadors, members, and initiatives. Events. So I can tell for events, learn new skills. Like it's just learning about new skills, get inspired, meet other women in technology near you. So all of our Women Tech Makers program is like kind of trying to help, of course, like run some variety of events every year, so we can just reach out to more people, right, to just get into tech. So Google Women Tech Makers runs a variety of events every year, from our Google summits or conferences, including actually International Women's Day, which is coming in March, and Google I/O, to hackathons, to local community-hosted meetups, all designed, to build expertise and community to help women thrive in technology. So that's how it is. So if you would like to, learn about the events, which is maybe like in the virtual era right now, but still, you can just participate. Join our membership program to stay in the loop for all Women Tech Makers events, so you can just hear from us in that membership program. I would recommend you to just click on the website, go to the membership, and then just sign up for that one. Meetups, ambassadors. So Actually, before that, I just got confused. I would like to call out the meetups part too. So our Women Tech Makers ambassadors collaborate within Google developers groups and broader developer community to ensure we are creating a diverse and inclusive ecosystem around the globe through our events. So they are doing regular, like meetups around the world to just let people, participate and then kind of bring that synergy, right? So these are one of the event types that I can tell. And IO, of course, that's another great opportunity for all women in tech. Like every year we just have a dinner, for example, or breakfast during IO. So to just, let all the women experience an amazing networking opportunities so that they can meet other women around them. Hackathons, one of the, again, event types that I can tell. We have been doing this for a while, online safety hackathons. So delivering online training and developing tools to improve online safety for women, we call it. According to Stay On, a program by Jigsaw to stop violence against women online. So we started this program. So Women Tech Makers and Jigsaw teams are working together to empower women developer communities across the globe to train in online safety. So organize hackathons and develop tools to improve women's online safety. So you can still, hear from us when you just go to the website, just join the membership program. So you will hear from us. IWD, one of the biggest campaigns that we have around International Women's Day, which is March 8th. So Women Tech Makers program team has convened over 200 global events across 52 countries annually to drive visibility, community, and resources for women in technology in the honor of, again, International Women's Day, right? So Google supports and celebrates women in technology through numerous initiatives, including the Small Business Supplier Diversity and Accelerate with Google programs, or the Google Cultural Institute, or our internal women employee resource group, and many more. So International Women's Day is an important day, and it's an important moment to recognize how women have influenced the tech industry and beyond. So if you want to learn more about IWD campaign and events, feel free to, check out the website again, during March time, so you can just learn more. These are the events that we have been doing that I can, tell in a summary. So I would like to just speak about some other initiatives that I listed over here. The other one is Ambassadors Program. So I just, mentioned that our ambassadors are doing some meetups or IWD events throughout the year. So what is an ambassador, I will say, right? So how can you become one? Women Tech Makers, maybe I should just start with what is an ambassador right now. So Women Tech Makers ambassadors are community leaders around the world who are passionate about achieving gender parity in technology. So as you know, we believe change starts at the grassroots level, and by building a gender equitable community ecosystem, we can begin to shift the industry as a whole. So as an ambassador, you will just benefit from the network that you have, or the access to all of the resources that we have, and then, support other women in tech. So Shweta, for example, or I'm not sure if Prachi is one of them, but Shweta, I know for sure. She's one of the ambassadors in Canada right now. So she's leading women in tech in the in her GDG chapter. So I'm really happy, actually, of course, about that one. So maybe we can just talk to her about her experience too as an ambassador. But that's the program itself. So membership, I will just touch a little bit about that one. Membership, you can find it again online. There are some sections about the membership program. If you're in your early career, so you can join, the Slack channel if you want, or if you're in the mid career, so you can join that one, or advanced one. So there are multiple tiers that you can join that moment, so you can, hear about the information that we have at Google. So initiatives, other initiatives, we have many more initiatives that are trying to do, for example, scholarships, or let's say, some other, like online safety hackathon actually is one of them. So, and then we have many more initiatives on YouTube channel. You can just follow YouTube's Women Tech Makers YouTube channel as well. So that's how Women Tech Makers program is, and we are trying to help, thriving women in tech. Before that, I would like to share some of the challenges that we are facing in the United States and Canada a bit. How even with these things that we are doing, we are still not there, right? We are still growing. We are still not there. So I will share some numbers with you. So as you can see, almost 47% of US workers are women. And actually that might have changed with the coronavirus situation right now, because I know how women workforce got impacted by coronavirus these days. I will share in a bit too, but that might have changed already. So right now, women currently remain, highly underrepresented in the software engineering. As you can see the numbers over here, 25% of the total workforce, and which is it includes 14% of the total workforce is engineering and computer science related jobs. So we have to, still work on it, right? We need to just hustle. We need to just, how can we achieve these numbers to be a greater inspiration, or we can say, okay, here's half and half, we just achieved this one. So lots of, statistics you can find online, but it's not about statistic, right? So how can we achieve these statistics around us? How can we lift each other up to just help, women in tech? We have a long road, of course, until we achieve gender equality in the workplace, but still I see, some positive trends across the tech industry. So some of the big companies right now, at 34% of women workforce. So we still, we need to do more, how we can just help women. That said, I will just share one quote again, how, we can change this, right? So it's just always people say, oh, it's been done this way. That's not the answer. So the most, Grace Hopper, who is the American computer science back in time. So she is an inspiration to all of us. And every year, there's a conference actually, which holds $30,000 women in tech, which is a great event. I actually joined this year too. So she shared the most dangerous phrase in the language is, we have always done this in this way, right? So that's how we can change that. I see these statistics, right? So we need to just do it. We know we have strength, resilience, that we can change the things around the world. We are so powerful inside that we don't need anyone or anything to lift ourselves up. I know this is kind of a pep talk, you might think, but it's how it is. Literally, it's how it is. Where there's a will, there's a way, I say. It is, if you want to, help, you just go out there, just, meet some women in tech, and then just see how you can help them. And then maybe they will help you too, in return. So use those opportunities, to change the world. I give this example in my life to all of the friends and family around me. So Greta Thunberg, maybe you already know her since she grew her mission for climate change, who is an activist about climate change, started by herself in the street to protest, but now she is followed by millions, right? So it takes a village to unite and change the world, yes, but it starts just within one person, right? So it just starts with one person, and then it gets to a snowball, and then it just goes through, all the struggles, all the challenges, yes, but then the world is getting more impacted by those millions of people, and then just shout out, just speak up, show your voice. So that starts with one person. Even if I can change one person's life with a program that I create at Google, then I'm lucky, right? So maybe that person will just go and then start their new business, and then they will just bring more employees, more women in tech. So that's how it is. It's a snowball effect. So feel free to just kind of go into some learnings that you can take, and then on how to be ally. Allyship is really important in this matter, that I saw. I'm learning from my environment as well, but that's how it is. That's the motivation that we need to wake up to every day, to bring more economic opportunities to developers, to techies, to women in tech. We strive and then we thrive, right? We hustle together. So again, I will go into the other perspective of the tech in a minute, because when I asked Shweta, what should I talk about, and she said, oh, maybe you should say, right, so it's not like when we say women in tech, always people think that you need to be software developer, you need to be a data science. It's just more so like the tech industry includes just only that. It's not only that. So many options in tech you can just work for. So you don't have to be a software engineer or developer to be in tech only. Think about me, right? So I'm working in tech. I studied chemistry, and then I just switched to marketing. I switched to UX, and it led me to again Google. Right now I'm working still in tech, and I am a woman. So there are millions of jobs out there, and you can find many jobs according to your passion and skill set. So these are the options that you can maybe you are maybe passionate about, like product. You can be a product manager, UX designer, user researcher, business analyst, technical recruiter, even just to be in the technology industry still. So of course, it's more about what you want to focus on. Sometimes, the barrier to entry can look very high to tech jobs. However, if you find the right position for your own skill set and passion, you don't have to be looking for other options that you think that, okay, I have to do this. It just literally tricking your mind. Okay, it's so high barrier to entry. So it doesn't have to be that way. You just step by step, just follow your passion. The reason I'm sharing this is because, people around the world think that it takes a lot of efforts to change their careers and get into tech, like my story. But there are many ways. So you just network, you follow your passion. You just hustle and then try to just be in the community, maybe to help others so that they can lift you up too. And I will say this, how we can do that. Time to join the forces. So I know, like I said, coronavirus hit women workforce more than men, as you can see on the news, which is unfortunate. But still, it's just this quote, I can tell. There's no limit. to what we as women can accomplish. And hundreds of thousands of women, nearly 8 times more than the number of men, dropped out of the US labor force last month that I read on the news. There is no historical example that we can look back in order to, provide insight into like the record number of women living pushed out of the women workforce or pulled away from the paid workforce because of the impact of COVID-19. I understand it, but I think, like every single hard situation brings more opportunities. Pandemic made us, think in a different way, like when it comes to social problems, right? A little bit more creatively, we are thinking. People, started learning like coding online, or how, they can just do other jobs than their regular jobs. So I see that happening right now. As I'm working with women in tech. But still, I think we will again have some like maybe like some companies working on we are going to have some companies working on the like changes. For example, as you can see, like people at offices are mandatory, right? But it's not. So you can work from anywhere when you have a laptop right now. So you don't have to be in the office at all. So pandemic just changes and shifts the like environment which is already built. So we have like lots of opportunities that nothing will be the same again, right? So it's just creating. We are kind of in the middle of like labor, I can tell, right? So it's just we are giving birth to new opportunities. So we will just come from our ashes to like a shinier person in the future. So again, how to be an ally and support the cause. I will say, please feel free to email me anytime. I will share in a minute or so how you can be an ally in the women workforce and how I can help you actually, with all the things that you are right now going through or anything else. So I'm here. I learned a lot how to be ally in the workforce or like in like in the world actually. So if you want to support the cause, please let me know. You don't have to be actually a woman, right? So how to be an ally means that all men can be allies who are enthusiastic about bringing more women in tech. So that's an important thing. With all the right now, with all the things going on, I think we will find a way. Like I say, together we are stronger. If any of you like wants to reach out to me, feel free to reach out. And then I would like to thank you all for listening to me. And here's my email that you can just see. And Shweta just came. I guess we will take some questions and everything. So that's all. Thank you.
Thank you, Kubra. It's such a nice story, and like I think many of us get motivated by your story that we don't need to be a techie by career to join the tech. You can study anything and you can join the tech as per your interest.
Definitely.
So, yes. So we got some questions from the viewers. Like one of the question is, any advice for overcoming imposter syndrome?
So yes, definitely. By the way, I'm still in the syndrome too. So it's like all of us are going through the same thing. So I am actually trying to overcome this situation too. And I can give some tips. It's just I guess here's what I learned from like people around me about this part. So imposter syndrome is, maybe I should just explain what it is first for those who don't know. So imposter syndrome is a syndrome that you think that, okay, I don't belong to this space, like I don't belong where I am right now, and then it feels like, okay, you are like, you know, lower in the lower, what is it, situation or status than the other, than the people around you. So in the workplace, what I'm right now doing is, okay, if you know, like if you are hired for that position, it's just so obvious that you can do it. It's not like, you know, people are kind of giving you the opportunity for like for your eyes, or you know, for your face, beautiful face, or anything else. So that's the mindset that I'm taking. Okay, I proved myself already. I'm, you know, I belong here, and trying to get rid of it by like kind of, you know, focusing on the work that I do. When you think about all the things, okay, I don't belong here, it's just, you know, they just gave me the job, how come, I don't know. But so I'm trying to get get out of this mindset all the time, saying that, okay, I need to focus on the work so I can bring more impact, so that way, you know, that will prove itself already that I belong here, right? So that's one tip I can give. Focus on the work that you do, so that will bring, actually that will overcome the imposter syndrome easily. So what else I can tell that I'm doing? Just actually, again, the other tip, as I mentioned, if they didn't like you, they wouldn't hire you, right? So it's like you are well prepared for your skills, with your skill sets and then passion, whatever it is. So that's why they hired you. It's not like only pure, you know, like just one thing that you are doing. It's maybe like it's just your skill set. So that's why you need to think about this one all the time. Maybe meditation even will help. So I do that too, like for imposter syndrome. Like you just realize your, you know, thoughts in the meditation, and then you catch them. Then you try to just focus on like the other things, but not think about that part too. So that helped.
Thank you, Kubra. And the next question is, um, how to get in touch with women in tech?
Yeah, so this is the easy one, actually. Like there are like multiple millions of groups, you know, on meetup.com, or like some, for example, if you Google search, okay, women communities, I'm sure there will be bunch of, you know, what is it? Bunch of communities around the world. So you can, you know, participate in those communities, and then you can meet people. And also, as I said, Women Tech Makers program is right now like allowing us to just network but in a better way. So if you can email me, of course, I can just, you know, give some other tips and tricks. But yeah, for example, just it's shared already underneath womenintech.org, or Grace Hopper Conference is another way. Women Tech Makers program, lots of, you know, initiatives around the world there is. Please, you know, feel free to email me so we can just get you meet people.
Okay, so the next question is,
That's an interesting question. I never thought about it. Yeah. Does any man program
yes,
exist?
does any men tech makers program exist?
Yeah, not now, but maybe, yeah. It's kind of, you know, the reason that Women Tech Makers programs was initially created is because, you know, like we have those statistics right now, right? So it's just compared to men, it's just lower in the statistics. So that's why we want to just fill in the gaps and then bring those together. But yeah, what would it be? I'm just curious, like what would it be different than the current situation? I'm curious. Anyways, so yeah, any other questions, Shweta, that we need to take?
Not Not now, Kubra.
Okay.
So I think we can wrap this session for now.
Okay, cool. Thank you. Thank you so much for having me, and then thank you, for giving this opportunity. That's why I say like every opportunity is really valuable in life, and maybe this will bring more, like open doors to all of us. So thank you, Shweta, for for organizing this event and having me.
Thank you, Kubra, for joining us. Like it's a really a valuable session today, and many people will get benefit from this. And like many of the people, they don't know about the Women Tech Maker program. So now today they get a very good insight about it.
Thank
So
you. Thank you.
thank you so much.
Thank you. Too. Bye bye.
Bye.
Oh, wow, that was awesome. It has been amazing 2 days of our DevFest session, having variety of activities, variety of sessions, such a great speakers and such a great insightful thought process that they have communicated with us. I'm pretty sure many of our participants would be uh, pretty much benefited with all the good ideas, the thought, the directions, the guidance, the mentorship they have got. Apart from that, from the tech perspective, I'm pretty sure that many folks got their questions answered, how to take a next step in particular technology in a particular area. We really had like such a diverse session that I guess everybody should have something out of it. I'm pretty sure people were watching this DevFest through different time zone, and they would be watching it into the recorded session as well, and it will go for a while. All right, now it's time to close, and of course, probably for next 2 days, I'm gonna have extra coffee, and I guess it's same and true with our other team as well. So maybe let's get all the team together and let's say thank you to our viewers, participants. Can we have Ram, Shweta, Prachi, Madhusha, Udesh, everybody on the screen? Let's have a closing notes comment from each one of us. All right. Hey, Madhusha, how are you feeling? You are having coffee every 2 hours?
It was it was quite the run, but it was good.
Okay.
I think the other ones bounced out. The other ones might have tapped out.
Mhm. Okay, so looks like Ram and Prachi, they got
No, there's
called
Prachi.
off. Yeah. Do we have Prachi here?
I'm here.
Udesh, yeah, thanks Prachi for joining. Udesh, you can also join. Thank you, Udesh. So
Yeah, well done.
pretty much it's all done now, and I believe that such a long session is not something we do all the time, but once in a while when we do that, there is a different layer of learning involved in terms of engaging folks and in terms of understanding what a wider audience want. So I thoroughly enjoyed the session throughout. I must say that yeah, it was tiring as well, I have to admit that, but at the same time I did enjoy it. I guess this is one of our session of one of its own kind. We had not done such longer session previously, which includes literally everything. Um, what we will do in future will depend on many thought process that we will have, like the post event discussions and stuff like that. But I will sincerely like to thank Madhusha, Udesh, particularly the way you set up the back end. That is amazing. Most of the time, I see like the backend person has to always stay engaged, always stay alert. If anything going wrong, the network glitch, you have to bring up something over there. While person on the front can take a pause at times, right? We can do certain thing, but the backend person. So huge thanks to Udesh on that note. Madhusha, your closing remarks for the session.
I think this is interesting because compared to in person, last year I was traveling around and I attended a lot of DevFests. But the beauty about this is, I guess, it's not, if you missed it, there's no worries. You can go back and watch it and you can engage with it. There are so many other platforms like we created. We have a Discord going on. You have your LinkedIn and Facebook community pages up and running. On top of that, I think this is the most convenient time to get acquainted with the broader community, even though it might not just be Google. Sorry, not just in Toronto. It might go as far as the global chapters. So I highly recommend leveraging it and consuming the content. And I think we had some great sessions. It related to pretty much like CTO, CIO, senior developer, manager levels to fundamentals where the students playing around and hacking things. So there's a broader variety of content. Don't just chase after swag. That's not the purpose of these events. And I really want to highlight that to all the students who are tuning in. Like it throws a big red flag even when we look for. So I work for Google, and when we try to recruit students or recruit anybody, like that's a big red flag. So try to learn something, try to engage with it, and then maybe we would love to see what you go build and how you implement some of these things that you learn overall, and then maybe we can host you at one of these events in the future. So keep that in mind.
All right. Yeah. Thanks, Madhusha, for bringing your thoughts around this. I feel like we definitely have a couple of more folks who are helping us from the back end, right? I have not personally met them, but if possible, can we bring them on stage as well so that we can thank them with all heart? Or do we have anybody else in the backstage?
No,
Who
I think this is everyone from the backstage. Now we're all in the front, so.
Oh, okay, great. Because I know we had a few more people who were backing us up, and um, anyway, so I will like to say thanks to those folks as well who never came on the front, but they were the kind of backbone in that sense. So, Prachi, how was the journey? Because the journey started basically from you, because you are our digital media coordinator, head, whatnot. So, promotion of the event till the end, and I know your job begins at the beginning and ends at the end, because even after the event you will have your job to do the post event activities. um, Thank you so much for that. Would like to know how you felt about the entire journey of this DevFest since you started planning about it.
Thank you, Vimal. And so, what I would say is, I would go back to 1 year before, when I had first time came into the DevFest 2019, and I had sort of joined at that time itself. And with all the insightful sessions, I had decided that okay, I'm going to join GDG and sort of help them out with marketing, and it would keep me in touch with a lot of people, a lot of networking to do, and a lot of information that I can have. It's been a great journey from then till now. With DevFest 2020, we've got such great speakers, such good networking that happen. Of course, marketing has a lot of things that go, um, a lot of things to do, a lot of social media to do. But I hope the audience enjoyed it. And we've had great registrations, great number of registrations as well. So I hope everyone is going to view the recorded sessions as well, and everyone enjoys it.
Yeah,
Thank
and as
you.
Madhusa shared, the beauty of this virtual session is that it doesn't go away from the day of the event. It stays there for a very long time. So there is pros and cons of the in-person session and the virtual session. Yeah, pretty much. Other thing which I would like to say with our participants who will be watching this at a later point, or if you are watching it now, we do not see anybody as headcount. We do not see you as just as participants. It is a community activity. We engage with each other. We see who has got what. I will try to learn from everybody who comes across me, and the same applies to the team. This is the very soul of this community learning program and this community learning activities. So if you have any thought, you want to join our team, we will be anyway posting in the comment section how you can join us. You can search GDG Cloud Toronto. Do not forget to subscribe and like this channel, because there are a lot more things that Madhusha is for sure bringing up. Probably Madhusha can highlight something is coming up in the recent 1 or 2 weeks or something, or you are planning to take rest now. I would, of course, waste a lot of your blood, right? Yeah.
I think we're going to take a rest for this week probably. But no, we have, and plus I'm going to bring some of your speakers back. I think they deserve another chance and maybe elaborate a little bit more. Like Tanmay's session was amazing.
Yeah,
I know
absolutely.
we got a lot of questions. I think let's see whether we can give him like a few hours maybe. And I know he's teaching a lot of kids on his own channel as well. I think plus he's from Toronto, he's from Brampton, he's from our neighborhood. So I think we want to give as much support we can give. Yeah, we have a 5-day series coming up next weekend. And then we have Alex Castillo is going to talk about his whole brain interactivity hardware that they're building with their startup. I know we were trying to get him here as well for one of the IoT initiatives. So yeah, another great session to join, and hopefully we can bring them, get the brand out there, and then maybe we can collaborate and run not just one, maybe we can do a number of different mini DevFests in the upcoming months. So excited
Absolutely.
about that.
Certainly, there are many speakers. When I see their profile and the kind of value they bring to the community, I personally feel like as a participant, there is a lot of takeaways. You talk about Tanmay, you talk about Alex. Alex, when I saw him first, it was just a small lightning talk for 5 minutes or 10 minutes where he demonstrated that brain controlled, web scrolling. And the first thing I did after that was I registered for the first device that whenever it is complete, I want it. So from the same day, I guess I have registered for that, and I would definitely love to not only see him, listen to him, rather experience what he has built and what his team is building. There are like so many amazing things people are doing. So it's a long way to go, I guess. With time, we are evolving in many different ways, and we try to bring the best we have. And every time we will go and see back and see how we can have better, engagement, more insightful speakers. Overall, I feel it was very satisfying. As I said, Udesh, the man, the backbone at the back, who makes sure everything runs smoothly.
Especially when my Wi-Fi dies. Like my Wi-Fi is very glitchy right now, and I'm like cutting in and out. Sometimes there's lags. Press the wrong button multiple times. So yeah.
Yeah, but we were able to maintain the momentum, I'd say, although it was a little bit of a little long stretch. But I think it taught you something about sort of running a marathon sort of thing, right? But yeah, everybody did their part, and just glad to be part of it. So
Absolutely. And it is amazing to see we as a team how we coordinated virtually all the time, because we are not doing it in person, right? So still through phone calls, through emails, through different channels, we are able to time together, get things done. All right. So finally, but last but not least, the
well,
person who
I
always
can't say
started
I can't say virtual all the time.
Oh yeah. We had a couple of meetings, of course. Not couple of meetings, I guess more than that. But the largest section this time, hopefully in 2021, when we do it, it's gonna be in person and it's gonna be as huge as we had visualized. All right. So
I
having
think
said that,
one thing I missed, and I have to say, is it's been a great support from Madhusha, and I've learned a lot of things of how he sort of organizes things, how he pre-plans. Of course, Vimal, Shweta, Ram, we keep talking and we keep planning small events. We have our own way. But with Madhusha coming in and sort of getting everything together, it's just been great and good experience with him.
nice to know that. And yeah, Madhusha does deserve all those beautiful lines for him.
Yeah, we learned how to manage.
So things, yeah.
Nice to know that.
So Shweta, your comments around everything that has happened in last 2 days.
Yeah, that was great, and We all say thanks to our family for supported us from last 2 days, especially.
Say
And
thanks to your
not,
daughter as well.
yeah,
I'm not
she's
sure
very
how she stayed
quiet.
without you. Yeah.
Yeah, and she's like staying away from me from last 2 days. That's a big achievement. And not just for us, even for our viewers, our participants, it's a long day for them too, and their family also supported them in this way. So thanks to the family. And now in terms of women in tech, few questions were there, like how to connect to women in tech. So you can connect with me on my LinkedIn or through the GDG Cloud Toronto platform on Twitter, LinkedIn, or any social media. I'm there, and I'll respond you anytime whenever you need anything, and I'm here to help. And if I cannot help in some ways, and I'll seek help from anywhere, maybe Kubra or Madhusha or anywhere. So whenever, wherever, I am here.
Absolutely. So nice to know that. And a very big word of thanks for our big team of volunteers who I didn't even get a chance to thank them, neither personally, nor virtually, nor through emails. And they were all the time engaged and helping us in all different ways. The team is so big, I cannot take names of all of them. So combined together, I will say a very big thanks to all of our volunteers. I'm not taking names because I don't want to miss any one of them. And we really have that big team, and having a session like 2 days, at every point of time somebody is there to support you. Of course it cannot happen with just a few people. So, and this is a team which we are working with. They have been helping us in all a small or big session all the time, in all different ways. Many a times they are the one who are taking care of things by their own, and they are, sometimes I feel they are doing it better. Like they are coming, but the ideas, it's not like we have to tell them what you need to do. They understand the very nature of this kind of involvement, and they come as part of it. So from my side, it's a very heartful thanks to our volunteers, the entire team, and I really love working with them. I would love to see, continue working with them for a very, very long time. Now, having said that, and not last but not the least, let's check the DevFest comments with somebody who has started all this, somebody who is the root cause of all the tiredness we had for last 2 days. So, Ram, over to you. What's your take and say on this?
No, I'm just so glad that there is a big smile on everybody's face. Two reasons. One, a successful event, last 2 days, continuous rotation. People haven't taken a break, probably. Especially, I know, Vimal, you have been like literally, I don't know if you had a sleep at all, like since yesterday. Uh,
So
you
Wima,
should
so
probably
Ram,
take a
turn on
big
your
break.
camera. Are you
Uh,
in bed already? He's in bed already. He's like crawling from the blanket.
No, yeah, it's just the internet issues. Like, I think I'll keep it this way now. But of course, like, keep smiling, and great work and great support from Madhusha and Udesh. Not to mention the support that we have got from volunteers, without whom this is not possible, right? This is not something that one guy or one person cannot pull all this together. Like, especially during times like a pandemic, coming together, delivering a 2 day session virtually from different places. And this is truly amazing. I think the synergy has worked very well. We should just keep this going. And of course, I want to make sure that you guys take breaks, spend time with your family and friends, compensate for the time that you guys have invested, rejoice with them, and hopefully we'll deliver more events online starting next month. And hopefully after the pandemic, we'll come together, have a huge celebration, and reward ourselves. Thank you, guys.
Absolutely, and yeah, that was lovely to hear from you, Ram. And I believe that everybody who's listening, including volunteers and participants, will get a sense of like how a team is being pulled, and we achieve something which ideally would not have happened if there was a single person. So yeah, one thing which I feel is certainly once we have done with this session. Uh, uh, you can always get in touch with us. We are available, we are reachable, each one of us on an individual note, or GDG, or Madhusha and his group. Um, so I will end my final notes by just saying a big thank you to everybody who's involved, whether you are participant, volunteers, or somebody who were helping us as an organizer. Thank you so much. That's my take.
Thank you, everyone. Thank you.
Thank you,
Mohan.
everyone.
Take care. Have a good day. Bye.
Thank you.
Bye-bye.
Thank you, everyone.
thinking about the people in the process, that technology cannot take more apart of that stuff. So I think that is the vision that we need to understand.
Nationalities and cultures and people here, and to me it's a safe place, especially when we're thinking about technology.